All right, in lesson 4.2, we're going to talk about triangle congruence by SSS and SAS. And we'll learn what those acronyms mean in just a second. So in lesson 4.1, we learned that if two triangles have three pairs of congruent corresponding angles and three pairs of congruent corresponding sides, then the triangles are congruent. Okay, so if all of the parts of the two triangles are congruent, then the triangles are congruent. Duh, makes sense, right? So if we know that angle F is congruent to angle J and angle G is congruent to angle K and angle H is congruent to angle L and FG is congruent to JK, GH is congruent to KL, and HF is congruent to LJ, then we know that triangle FGH is congruent to triangle JKL. But, however, this is more information about the corresponding parts that we need to prove that triangles are congruent, okay? Hence the acronyms SSS and SAS, all right? So today what we're going to do, we're going to learn two different postulates that we can use to determine if the triangles are congruent, whereas in lesson 4.1, we had to list all three congruent pairs of sides and all three congruent corresponding pairs of angles as well. So we can prove that two triangles are congruent without having to show that all corresponding parts are congruent. In this lesson, you will prove triangles are congruent by using the first postulate, three pairs of corresponding sides, and then in the second postulate, we'll have two pairs of corresponding sides and one pair of corresponding angles, okay? So look at postulate 4.1, side, side, side. SSS, okay? That is what the acronym SSS means, side, side, side. So in the side, side, side postulate, it states that if three sides of one triangle are congruent to three sides of another triangle, then the two triangles are congruent. So if side AB is congruent to side DE and BC is congruent to side EF and CA is congruent to FD, then we can say that triangle ABC is congruent to triangle DEF by side, side, side. All right. So looking at the first example with using side, 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 all right, it asks us to list what's given and then to prove that these two triangles are congruent. All right, so let's look at what's given. Well, we know that these tick marks represents congruency. And if you have the same amount of tick marks, then those sides are congruent. So side BC is congruent to side BF, and CD is congruent to FD. All right, and so we need to prove that side BD is congruent to side BD, all right? Well, that is true by the reflective property of congruency, all right? So what we're saying is the side is congruent to itself, but it is, both sides are, they contain two different triangles. Yes, they have the same length and the same name, but technically they are two different sides. So here we can say that triangle BCD is congruent to triangle BFD by side, side, side. And then you can also show relationships between a pair of corresponding sides and an included. All right, so this piece of information is very important, especially when we get into the next lesson, 4.3. When you hear the word included, think of the word between. So if we say the included side, then we're talking about the side that is in between two specific angles, or vice versa. If we're talking about an included angle, then it is an angle that is in between two specific sides. All right, and then in 4.2, this is where the included angles come into play. So we have SAS, side angle side, and it states that if two sides and the included angle of one triangle are congruent to two sides and the included angle of another triangle, then the two triangles are congruent. So here, if side AB is congruent to side DE and angle A is congruent to angle D, and if AC is congruent to DF, then these two triangles, ABC, are congruent to DEF by side angle side. They have two congruent corresponding pairs of sides, and the angles that are corresponding and congruent are included, which means that these angles are in between these two sides. All right? So in part 2, it asks us, what information do we need to prove that triangle DEF is congruent to FGD by side angle side? So let's list what we know. Well, we know that EF is congruent to side GD, all right? And then we also know that side FD is congruent to side FD by the reflective property of congruency, all right? So here we have two sides that are congruent. So we need to know what the included side is. Now, the included side has to be the angle that is in between these two sides. So here we have angle EFD and GDF. So what needs to happen is for angle EFD to be congruent to angle GDF. All right? And if we prove that these two angles are congruent, then we say that these two triangles are congruent by side angle side. All right, and then in the second part, it asks us what information do we know to prove that triangle LEB is congruent to BNL by side angle side. Explain. So let's list what we know. Well, we know that angle ELB is congruent to angle NBL, and we know that line LB, or side LB, is congruent to side LB by the reflective property of congruence. All right, and we need to know that if the sides EL and NB are congruent, because those two are the side that will make angle ELB and NBL included. So we need side EL to be congruent to side NB. All right, and then in part 3, we're just naming if the triangles can be side, 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 side angle side, or if we're not given enough information. All right, so look at letter A. Here we have two pairs of corresponding congruent sides and one pair of corresponding congruent angles that is included. It is in between those two sides, so A is yes by side angle side. All right. And B, if you look here, we have the included angle, but here we do not, okay? So this is not enough information because the angle is not included in between these two sides, all right? In part C, we have 3 pairs of corresponding congruent sides, so these triangles are congruent by side, side, side. And then in D, we have the same thing. We have 3 pairs of congruent corresponding sides. So we have side, side, side. Or if we notice that here we have 2 intersecting lines that form vertical angles, and we know that vertical angles are congruent. So not only is this example side, 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 but it also could be side, angle, side.